In this example for polymerization, we're going to try and polymerize 2-methyl butene. So we're going to try and polymerize this, and we would first need to know what the structure is. So since the main chain is of butene, which means that they're going to be 4 carbon atoms, and 2 means that the double bond would be between the second and the third carbon atom, and 2-methyl means that there's going to be another carbon chain, a branch of carbon, and it's only going to contain 1 carbon atom, and we're going to draw all the hydrogen atoms now. So these hydrogen atoms are then drawn. This will have 1 more hydrogen atom. This has 4 bonds which are complete, and this has 3 hydrogen atoms. This also has a total of 3 hydrogen atoms. Now, the first thing before drawing a molecule of polypropene is that I would need to redraw this, and the rule is that I need to keep the carbon double bond carbon in the center on the horizontal axis, and I need to bring everything, all the other bonds must either be brought above, they should be drawn above or below these double bonds. So we have this hydrogen atom, this is drawn correctly, it's drawn in the upward direction. We have this CH3 branch which is drawn downward, so that's correct. I need to get this drawn correctly. This CH3 must be drawn underneath these carbon atoms. I need to bend this CH3 and bring it below, and similarly this CH3 over here, that needs to be brought upwards. So I need to redraw this molecule. So let me redraw this molecule. This molecule would look like something like this. It would look something like this. I'll draw the carbon double bond carbons in the center, and there's a hydrogen on top. So I'm going to draw, and I'm going to use the compressed version because you have so many bonds. So it's going to become difficult. So instead of writing CH3 and drawing all the bonds, I'm just going to write C and H3. So I have a CH3 below, and the bonds that I'm going to pen are this. Number 1 is the CH3 bond. Instead of drawing it to the right of this carbon atom, I'm going to draw it below this carbon atom. And similarly, this bond over here, this CH3 which is attached to this carbon atom over here, this CH3 needs to be drawn in the upwards direction. So instead I'm going to draw it in the upward direction. There would be nothing to the right or to the left of these 2 carbon atoms, this carbon atom and this carbon atom. There shouldn't be anything to the right and to the left of this carbon atom. Any bonds, they must either be brought downwards or upwards. So now I've drawn the structure of propene. I am now going to draw repeat units, and I'm going to try and polymerize this structure. So the repeat units are going to be that you're going to have the same structure repeating over and over again. You have a CH3, then there's another CH, and let's draw 3. Remember to at least draw 3 repeat units when they ask you to draw the partial structure of a polymer. It's essential because 2 repeat units would be too less. So at least draw 3, or even better would be 4 repeat units if you have the time. So let's draw another one. And the next thing that I'm going to do is I'm going to, all the double bonds under high pressures and high temperatures, they're going to break up. So I'm going to, instead of drawing the double bonds, these double bonds will get converted to single bonds. So I'm going to put single bonds in their place, and if you look at the molecule now, each carbon atom especially those lying in the middle. This one is now making just 3 bonds, and this one is also making 3 bonds. So they end up making a 4th bond with each other, and they link up. This carbon atom over here is making 3 bonds, and this carbon atom over here is also making 3 bonds. So they're going to bond together, and they're going to link up, and they're going to make their 4th bond. This carbon atom over here and this carbon atom over here are making 3 bonds as well. So they're going to end up joining with each other. This would continue on with another propene residue, and this would also continue on with another propene residue. Remember, don't miss out these continuation bonds. If you don't draw these continuation bonds, you're probably going to lose marks when you're drawing the structure of propene. So this is your chain. This is the chain that's going to be formed, and you would then be asked to either draw this structure, the partial structure of this polymer, or you can be asked to draw the compressed version. So the compressed version for this molecule of let me circle. So I've drawn a circle around it. This is the repeat unit that's repeating over and over again. So this has 2 carbon atoms. It has an H on top, a CH3 at the bottom, and a CH3 at the top, and a CH3 at the bottom, and they are continuation bonds. And this is a structure that's being repeated over and over again. So I'm going to draw square brackets around it and put n, which means that it is being repeated n number of times. N could be 1,000, it could be hundreds of thousands. So this structure, this repeat unit is being repeated n number of times. So this is a molecule of we were drawing. This is the molecule of poly, and it was 2-methylbutene. Butene. So now this is a polymer of poly 2-methyl butene. We will now try and attempt to polymerize 3-ethyl pentoene. I would first draw the structure of pentoene. Pent means pent over here means that it has 5 carbon atoms. So I'm going to draw 5 carbon atoms. That's 1, 2, 3, 4, and 5 carbon atoms. And 2-ene means that the double bond is between the second and the third carbon atom. And 3-ethyl means it indicates that there's a branch on the third carbon atom, and it's an ethyl branch, which means that there's going to be 2 carbon atoms over here. So I'm going to draw all the hydrogen atoms now. Next, this is going to have a total of 3 hydrogen atoms. This is going to have a total of just 1 hydrogen atom. This already has 4 bonds. This one needs 2 more bonds, so 2 hydrogen atoms. This one needs 3 more bonds. Similarly, this one needs 2 more, and this one needs 3 more bonds. Now this is the structure of 3-ethyl butene. Now what I'm going to try and do is that remember, whenever you try to polymerize something, you have to redraw the structure, you have to bend a few chains. So what I'm going to do is I'm going to keep this carbon, double bond carbon, on the horizontal axis. Anything that is to the right or to the left, there shouldn't be anything to the right or to the left of this carbon, double bond carbon. Everything must be either brought upwards or downwards. So what I'm going to do is this part of the structure is coming to the right of this carbon, double bond carbon. So I'm going to try and draw it in the upward direction instead. Similarly, this chain is coming to the left of this, so I'm going to draw this in the downward direction. So I'm going to bend these two. These two are fine. This hydrogen is in the upward direction, and this chain over here is coming below that carbon, double bond carbon. So these two are fine, but I would have to bend those 2 chains which are on the right and on the left of this double bond. So I'm going to redraw the structure now. So let me redraw it over here. So I'll put the carbon double bond carbon in the center. There's an H on top, and I'm going to, instead of drawing all the bonds, I'm just going to write CH2 and CH3. This is this particular structure that I've just drawn. It's I've just drawn this structure right now. Now let me rub this off. Now what I'm going to try and do is I'm going to try and bend the two structures that I've mentioned earlier, and they would be drawn in the upper direction. So I'm talking about this structure over here. Instead of drawing it to the right, I'm going to draw it in the upward direction. So this would be, there would be a CH2 and a CH3 group. Similarly, I'm going to draw this structure over here in the downward direction. So they're attached to this carbon atom over here. So instead of drawing it to the left, I'm going to draw it below this. So this is the shape of 3-ethyl pentene, the bent shape that I've drawn now. This is the shape that I'm going to use for polymerization. So I'm going to move next to polymerizing this substance. So let's redraw this and draw multiple structures like this. We will have a carbon double bond carbon in the center, and there's going to be a CH2 and a CH3 group. That's it. That's an ethyl chain, a branch. Similarly, there's one below that, and there's an H over here and a CH3 group over here, and I'm going to draw at least 3 structures. So there's a CH2 and another CH2 and a CH3, and there's a CH3 group over here and an H on top. And let's draw a third one. And an H on top. And so I've drawn 3 structures now, and these 3 are now going to bond with each other. The first step is that the double bond breaks. So I'm going to rub off the double bond, and it breaks under high pressure and high temperature and gets converted into a single bond. So I'm going to rub off these double bonds, and instead I'm going to draw a single bond instead. So this double bond breaks and gets converted into a single bond, and now this carbon atom over here is no longer making, and this carbon atom over here, they're both making 3 bonds. They have 1 bond less, so they're going to try and complete the bonds. Their 4th bond would be made between them. So these 2 carbon atoms, they end up bonding with each other. Similarly, these 2 carbon atoms, this is making 3 bonds and this is making 3 bonds. Both of these carbon atoms need to make a 4th bond, so they end up making a 4th bond with each other. And then you have continuation bonds on both sides. This carbon atom needs to make another bond, so it's going to make a bond with something to the left of this particular chain. So this means the continuation bonds means that the structure is still continuing, and a compressed version of this same structure would be that you are going to draw a partial structure, or the repeat unit, which in this case is going to be this part that is being repeated over and over again. So you're going to draw this part, a CH2 and a CH3, and you have a CH2 group and a CH3 group below, and there's an H and a CH3 group on this side, and this part is being repeated over and over again. You're going to draw the continuation bonds, which would mean that this structure is still continuing, and then you're going to draw square brackets around it, and you're going to write n, where n is the number of times this particular structure is being repeated over and over again. So that's how you're going to try and polymerize 2-ethyl butene, and sorry, it was 3-ethyl pentoene. This is how you're going to polymerize this structure. So remember, I'm going to revise this. Remember, draw the carbon double bond carbon like I've drawn over here, and make all the structures either above or below it, not to the right or to the left. So this structure over here, which was drawn to the right, and this structure over here, which was drawn to the left, they must be drawn either in the upward direction or the downward direction. So that is exactly what we did over here. I'm going to highlight that in blue. So this CH3, CH2 and this CH3, they were bent. They were made up in the upward direction and the downward direction. And that's how, and you're going to repeat this same structure over and over again, and you're going to get rid of the double bonds and instead make a single bond and then link up the chains together. And that's how you get this particular structure.